Indeed, I think a key priority for the Kids First program is data use and access to accelerate research. And much of the metrics for the initial 1-year timeline in which the Kids First program has been funding the DRC have focused on empowering data access and use as the initial rollout of the DRC. And today what we hope to do is really highlight those efforts across the entirety of the day at where we are, the DRC, 1 year essentially into the program, and where we're trying to head. I think it's also important to recognize that the Kids First program funding of the DRC and the entire program itself is a highly unique and unprecedented initiative in the pediatric landscape and perhaps even beyond, in ways that brings both challenges and opportunities for the community itself. We don't yet have all the answers, but we are going to be an incredibly engaged DRC working with the community to do this. And indeed, the only way we can solve many of those challenges is going to be through collaboration across almost every level of the program. We noted the high level of collaboration across the NIH itself, and this is going to remain true within the DRC and as we move forward through collaboration. The first session is really going to focus on the thought space around the Kids First Data Resource Center and the first year of its existence, really how we are trying to empower data access and use through the first initial rollout of tools and platforms, the importance of that partnership and collaboration across the community and especially the patients, foundations, and community members, and then again, in alignment with the vision of our programmatic mission, the acceleration of the translation of infrastructure tools, data, and resources into the immediacy of research on behalf of patients. And we'll give you examples of that in this first session. So as I highlighted, just like at the NIH level, we have tremendous collaboration across the NIH, even within the DRC. As CHOP is the lead site for the program, we are really distributed in partnership across the dream team of stakeholders that bring to the development and resourcing of the DRC really a best-in-class environment. Kids First DRC is really an initiative that is part of a rapidly expanding landscape of big data, cloud-based compute, and the combinatorial use of data sets for enhanced discovery. And in order to achieve that, there are both technical, regulatory, and discovery challenges that require an extremely diverse team to really address this fully. This team is then further separated into 3 cores within the DRC. The DRC cores are respectively responsible for the building of the data resource portal. The data coordination really is the intake, management, harmonization, preparation of data for use and distribution in partnership with the dbGaP process of data sets to the community. And then the overall administration and outreach functionality to support both the smooth operational efforts of the DRC itself across a very diverse and collaborative team, but even more importantly, the inclusion of the community itself, patients, foundations, researchers, clinicians, and researchers as part of the authentic team of the DRC itself. As James mentioned, the Kids First vision is a highly aligned vision with the pediatric community, prioritizing the alleviation of suffering from childhood cancer and structural growth defects. Collaborative research and data sharing are the 2 other really high points of the mission. And for us, this is the way we are going to metricize and measure our success, whether or not we achieve this mission in a timely manner. And timeliness is a really key component of our efforts. The DRC really engages a innovative hypothesis. At its core, the DRC and the program itself.
Can you switch to the table?
Yep, I'm switching. The DRC and the program itself is focusing on harnessing knowledge that potentially shared across the developmental space of the growth of a child, and the disease landscape therein, and the processes that drive pediatric cancer. For a long time, the community has recognized that pediatric cancers are likely to have a differential origin than most adult cancers, but the community has come to recognize that there are opportunities for enhanced discovery by looking at the data, the science, and the information across these two landscapes. And in a brand new way, the Kids First program and the DRC is leveraging these opportunities through the data sets being populated within the program. And the challenge is to harness what are really tremendously complex environments on their own on either pediatric cancer or the developmental landscape of structural birth defects. By integrating and partnering across those two domains, reduce the complexity to provide opportunities for discovery. And that is a recurring theme, the recognition that these are highly complex diseases, highly challenging diseases for both the patients and the community themselves, as well as the researchers, but that there is sufficient information and precedent that through the integration, harmonization, and presentation of these resources, the complexity can be reduced in ways that can promote discovery. The mission, as defined by James, is very clear, but the mission is also informed by the underpinning provided by the community. And for those of you who are interested, you can Google Gabriella Miller and find her video that really launched the program. And an additional mandate, not explicitly stated in the mission, is to hurry up. And I think that is an additional metric that we are going to be measured by across the landscape, is the acceleration of discovery through the emergent platforms, tools, and resources that are being empowered within the DRC. So acceleration is a key component of every task that the DRC undertakes. And that can be both challenging, but is also a mandate by our community. Now, Gabriella actually succumbed to a rare brain tumor called Diffuse Intrinsic pontine glioma. This is one of the most challenging tumors of its kind, for which we have no therapeutic way of intervening by and large. And the history of diffuse intrinsic pontine glioma extends very far back. Indeed, in the 1950s, Neil Armstrong's daughter was herself a victim of diffuse intrinsic pontine glioma. And the challenge before the Kids First program and the DRC is to change the course of these narratives, because the exact same outcomes and the exact same therapies by and large that were provided to Karen Armstrong were those that were implemented for Gabriella Miller. And the reason for this is a lack of knowledge of the disease and a lack of understanding of its underpinnings. And I think these are the kind of things that we are positioned and poised to transform, and you'll see in some of the presentations later how rapidly that can actually happen the minute information enters the landscape. As I mentioned, these are challenging diseases for which we currently have no way to cure these patients. And again, alleviating suffering and changing the course is going to be a key mission, and we cannot wait another 50 years to do this. And so our mandate for acceleration is going to be measured in much more timelines for this. Now, when Gabriella speaks in the video that really supported the launch of the Kids First program, she is very clear about her motivation to actually support all pediatric patients. And this is actually something we see recurrently within our community, and especially in children. Their mandate is on behalf of all children. And without even knowing it, Gabriella herself was actually right. It turns out that 8 years after the genomic sequencing of another rare disease called fibrodysplasia ossificans progressiva, and a year after Gabriella died, DIPG was further characterized by an initial set of studies that discovered a still not understood intersection between two diseases, one that drives aberrant bone formation and deformities, and another one that causes cancer in the brain. 1/5 of patients with DIPG share the exact same mutations in ways that the two communities failed to recognize, failed to harness, and failed to be cross-informed, not because they were not interested because they did not have platforms that supported such intersection, and resulted in a missed opportunity and longer timeline for the discovery and implementation arena. And again, these are lessons we are bringing to the Data Resource Center and the platforms in real time. Now, our community is highly engaged in a large number of discussions around data sharing. The large amounts of data being generated both by the NIH and outside of the NIH has driven a narrative and a discussion around what are the appropriate stewardship mechanisms for data sharing, what should happen to data, and how can data be empowered. However, we also recognize that the availability of data is not sufficient to actually impact change. I have up here a quote from the 1800s that really looks at data as it was stored at that period of time, which was in museums and libraries. And this narrative of storage and cataloging that's insufficient to actually empower information existed then and also exists now. On the right-hand side, I have a tweet just from yesterday from two very prominent and active investigators in the cancer landscape. The first tweet by Lou Zimmerman really highlights a challenge that historically there have been other efforts that provided data. The SRA itself and the DBGAP provides data currently. But we recognize that the Kids First DRC's mission can do more than just provide data. The data provisioning or availability is really just the first step to the discovery process. And then this is a very unique time within our community and within the technological landscape to take additional steps beyond simply access to data. And this is really core to the mission of the DRC. So we've been building the initial version of the DRC platform. And so one of the things that I'd like to try is to ask the question, why is this happening now? And if lots of data isn't really the answer, what is the answer? What has brought us to this point of a data commons environment where many initiatives in the NIH and otherwise are looking at ways to empower data besides access? And why is this a unique moment in time for the community to engage in really defining what we think is a new way of doing science that up until now has not been fully empowered? So I'll take you through a very brief historical context for these efforts. Back to the 1950s, to the time of Neil Armstrong and Muffie. And at that time, a couple of key transformational events took place. The first was Claude Shannon's really inspirational work around the theory of communication and really what had become known as information theory. Up until this work, people did not have a very good way of actually measuring the amount of data that something potentially has. What does that mean when something has a certain amount of data? And how can that data be essentially communicated, transferred, sent, compressed, analyzed, and what are the determinants, right, from a formal analysis around data itself and information? And this was a requirement for humankind to actually take the next step beyond the initial conceptualization around what information really is and how we measure it, and into the very initial first steps of the internet with the formation of ARPA. Once people could measure and understand the flow of data and what data actually are, this set the stage for creating a network of how data should flow between environments. At the same time, an entirely new theoretical environment emerged that began to redefine almost any scientific process itself across the entirety of the scientific domain, from quantum mechanics to basic biology, in terms of information. Really recognizing that if observations can become zeros and ones and processed through a computational environment and produce zeros and ones, this really matches one-to-one to the scientific process of beginning with observations and coming up with a theory. For those of you who have been doing science in the last 10 years, I suspect you can see the role that computation, computers, analysis, and the internet really have within your own efforts and how they trace back to these early conceptualization around information. Now, at the exact same time, the genetic code was also discovered, at least its first iteration by Francis and Crick. However, if you really probe the history from that time forward, there was really a separation at birth. Information theory, computation, computers, communication evolved dramatically, right, over the last 50 years. But it wasn't until the 21st century that the biology space of information really began matching to the computation and information theory landscape. It wasn't until we could begin generating large-scale genomic data sets and math that the challenge and opportunities of converting a genomic code into zeros and ones suddenly brought to the community opportunities to rethink how we do biology and how we can leverage all the work that others have done in entirely different domains that intersect communication, computation, information. And this is really where we fit as a community and as a data resource center. Complexity and randomness is really what drove the disease in patients like Gabriella. It's an entirely, as far as we can tell, random event in terms of how it is that across humankind, some children are unfortunate enough to become patients of these diseases. But information, computation, and communication are exactly the processes that are inherent in the biology itself. The genomic code is a code of information. The first therapies and the therapies that still most DIPG patients get, for example, today, are radiation therapy. Radiation really tackles the code itself. Radiation therapy essentially damages the DNA as a means of trying to suppress information transfer, computation at a cell level, and communications between cells to inhibit the cancer. Unfortunately, those efforts are non-selective, and as you can imagine, such efforts not only target the dividing cells of a particular disease, but the dividing cells of a growing child. And these are the challenges that face us as we try to move into the precision medicine landscape of understanding the disease itself at the molecular level, at the informational level, and in ways that harness communication amongst our community. And in doing so, it is without a doubt defined by mathematical formulas that we will reduce complexity and randomness. And in many ways, reduction of complexity and randomness will align with the alleviation of suffering. Those two things end up being synonymous. And so you can see that these highly technical terms and technological and bioinformatic efforts really align in mission of the Kids First program in ways that we are really excited to engage, but admittedly are still figuring out. I'll go through a couple of the design principles that still guide us at a little bit greater detail as we move forward. And the hope is that throughout the rest of the day, the presentations, the demos will demonstrate how we are walking our way through fulfilling these design principles. The first is that the discovery process really has to have a complete data life cycle. We begin at the analog phase of a patient, convert the biospecimen, the blood sample into a digital landscape of information and data, but then the process is not complete until it comes back to patients. Simply stopping at the digital component is not going to satisfy the mission, and that is really why we have such extensive integration and partnership with the patient community and clinical landscape from the very first instance of the DRC. The processes that you'll see invoked within the DRC and the platforms really look across the following workflow of trying to transform data, which from our perspective is simply the raw data that comes off the different platforms that generate it, to information, which is really a version of usable data that's been harmonized and can be actually interpreted. And once that happens, it can be analyzed and becomes a knowledge base for use and actually implementation for actual impact as applied to patients. And this is the pipeline that we hope to actually drive in real time as we develop the resources within the Kids First. And much of what you'll see today is really focused on really that first two-step process of empowering data and the creation of information to support the next step of knowledge creation. And you'll see a bit of some of those examples that this is really where we're going to develop many of the other features moving forward. The other things that I wanted to highlight are some of the unique commitments to not only supporting diversity and collaboration across domains. That is going to be implemented as well as reflected within the tools themselves, but across organs, across data types that are collected longitudinally in time, across data sources and the community itself, from both other cloud-based and large-scale data initiatives, as James highlighted, across NIH, ICs, and efforts, and the involvement of consortia-based initiatives that are also generating large-scale data sets that are contributed to the DRC. And all those then also intersect with a very diverse community across researchers, healthcare professionals, patients, family members, and community members. This is a tall ask of the DRC and our partners to fulfill the requirements and needs of such a diverse landscape. Historically, most initiatives have defaulted to restricting focus as a means of addressing this challenge. But as I highlighted earlier, this is really where we see the opportunity emerge, is through the intersections and collaboration occurs across a diverse environment. This is how complexity will be reduced within our efforts. I decided to insert this slide because I was helping my 8th grade son in his first quiz of the year, where they were looking at the scientific process. Much to his chagrin, this interested me way too much. But part of the right reason for this was because on the left-hand side is what he is being taught. And this is what we're all taught, and unfortunately this is what I have even taught, which is a process of going from observation to hypothesis to analysis and conclusion. But this process of performing science is incompatible with the Data Resource Center and what actually has to happen. Nowhere along the way is there a discussion of how data gets communicated, intersected, collaborated on. The view of traditional scientific process is really as an individual, locally, within their own environment, in ways that we now recognize do not actually achieve the discovery that are necessary. Instead, new emergent configurations of the scientific process are being developed. This is from Berkeley, from an NSF-funded effort, really looking at how research is actually currently being done, at least leading-edge research, which looks at really a much more holistic approach and across a much larger landscape of impact, including the benefits and outcomes to the community that research is supposed to serve, and how the community itself is required for the actual testing of the ideas that are being proposed. And this is really what we're trying to create within the DRC through the initial tools to support this process of science as opposed to the traditional model currently in the hands of my 8th grader. The second set of design principles that I wanted to go through are, again, abstracted principles for us. These essentially provide our guidelines as we develop new tools and prioritize their development. Without these, we do not think we will be successful in the kinds of efforts we are undertaking. Whatever we build and whatever we do have to prioritize discovery and knowledge creation as a non-local information-driven phenomenon. Second, we must maximize the number of information users and processors at every step. At no point should the system support or require the singular, the individual as the bottleneck for discovery. At each point, the systems must support collaboration and integration across users. Diversity is key, and this is actually a tenet of information theory, that as you diversify information, you actually increase what information can do. And again, you see that already across the landscape of our program to date, and we'll only be continuing doing this as we move forward, not only with each new XO1 cohort, but as we engage additional partners and additional community stakeholders. Diversity can only succeed if you maximize connectivity. Diversity without connectivity is confusion. So connectivity occurs across diverse efforts is a mandate for this to succeed. So a combination of diversity, connectivity, and large numbers is the successful recipe within the platform. And lastly, across this, there has to be frictionless flow of data. Movement of information is key. Most of us are used to frictionless flow of information in our daily lives with our iPhones or other devices. Such frictionless flow of information has to be empowered still in a regulatory compliant way, but in ways that do not inhibit or restrict the time quotient that Gabriella imposed on us. So you can, as of today, and actually as of last week with the launch of the portal, and I just want to make sure that we capture every audience member as early as possible. If some of you do not stay for the rest of the presentation, you can go back to the kidsfirstdrc.org, create your account, and begin to actually make discoveries, collaborate, and share data. Some available data sets have been in the DRC for some period of time, highlighted at the top, and along with the launch of the portal last week, we also have our first community-contributed resource, the Pediatric Brain Tumor Atlas initiative, which has been newly released last week and is available. And in most of these studies, you'll be able to begin the kinds of studies that we actually just defined earlier, looking at ways that such diverse data sets can actually empower discovery by combining, interoperating, and querying across very large data sets at this moment in time. So please go to kidsfirstdrc.org and begin creating your account. You can create your account in the absence of any initial EBGAP access, as was highlighted earlier, to engage this registered user environment that provides you access and opportunity to develop your own portal experience around existing data sets